Hello everyone, I'm Mohammad Asad Rahman Rafi. The paper I want to cover is about a critical analysis of the MemPalace architecture. So MemPalace is an open source AI memory system that exploded in April 2026, and the answer they wanted to find out is that uh, the architecture that's borrowed from a 2500-year-old human technique, is the ancient metaphor really actually doing anything, or is it just a great branding on top of standard engineering? So so first, some context on why this paper exists at all. MemPalace launched in early April 2026 and became one of the fastest growing AI projects in the GitHub history. Nearly 48,000 stars and about 6,000 forks under 2 weeks. So that's extraordinary. The claim that drove the AI hype was 96.6% score on long memory eval, so which is a hard benchmark specifically designed for to break AI system memory systems. The project also claimed to achieve this without any LLM inference at right day, so which actually makes it essentially free to run. So you can see why people get excited, and that's exactly why it needed independent scrutiny. So a 2500-year-old promise applied to AI. The core concept comes from Simonides of Chios, ancient Greek orator. The idea is that humans memorize information better when they specialize it. So you imagine a building, you place facts in specific rooms, and when you need to recall something, you mentally walk through the building to find it. It's called the method of Loci or Loki. The MemPalace translates this directly into a data structure. Wings are top level domains, a project, a person, a topic. Inside wings, you have rooms for specific subjects. Closets hold complex pointer indexes, and drawers hold the actual raw text chunked at 800 characters each. It's a beautiful concept. So the question the paper asks is, does that hierarchy actually change how retrieval works? The special metaphor is a flatware to database. So, and here's the central finding: it doesn't. Beneath all the architectural terminology, MemPalace is a single flat ChromaDB collection. One table called MemPalace Triads. Every wing, room, hall you see in the UI maps to a JSON metadata field on a database row. When you navigate to a wing, what's actually happening is a where filter, where wing equals signs. For example, that's standard metadata filtering. It's available in literally any vector database, and it has been for years. The palace is a beautiful abstraction on top of something entirely ordinary that doesn't make it useless, but it matters for understanding what's really driving the performance numbers. So silicon does not have a hippocampus. So here's why the metaphor cannot transfer at a deeper level. The meta method of Loci works for human because our brains have dedicated special navigation system, place cells and grid cells in the hippocampus that literally fire when we mentally move through a remember space. Memory and spatial navigation are neurologically linked in humans. A vector database doesn't have a hippocampus. When MemPalace retrieves something, it's doing approximate nearest neighbor search in 384 dimensional mathematical space using an embedding model called all mini LM L6 V2. There's no special traversal happening. The metaphor is powerful for us. It helps us reason about where our information lives, but it's not doing anything for the AI. So deconstructing the long mem eval performance. So basically, where do the impressive numbers actually come from? Let's walk through them carefully. The headline claim was 100% on long memory eval. The paper found this required undisclosed LLM re-ranking that wasn't part of the standard benchmark setup. So when corrected, the hybrid score on held out questions is 98.4%, still great. The 96.6 number, the most people cite, is what you get just from ChromaDB's default embeddings on uncompressed verbatim text. The Palace structure contributes nothing to that score. So and then there's AAK mode, the project's custom lossless compression. When you turn it on, accuracy drops from 96.6% to 84%. So the compression they marketed as lossless cost you about 12% points on recall. That's a significant finding. The contrarian brilliance hidden in the hype. But here's what the paper pivots, and this is the part I find most interesting. Despite the overstated claims, the MemPalace actually proved something the field needed to hear. For years, the assumption was that good AI memory requires an LLM to read every conversation, decide what's worth keeping, extract structured facts, and store those. Systems like MemZero and JEP are built on that assumption. MemPalace said, what if we just store everything verbatim and retrieve it well? And the benchmark shows that approach matches or beats extraction-based systems. That's a genuine intellectual contribution. It challenged a consensus that had hardened without being tested. The verbatim fast philosophy. So why does verbatim storage work so well? Because extraction introduces to failure modes. The first is false negatives. The LLM reads a conversation and decides something isn't important enough to keep, but it guesses wrong. Now that information is gone forever. The second is semantic distortion. When the LLM rewrites content into extracted facts, it changes the exact wording. And because vector search relies on semantic similarity between the query and the stored text, distorted text retrieves less reliably than original. So MemPalace eliminates both problems by never making a right time judgment. Everything goes in raw. You trade storage efficiency for zero information loss, and the benchmark suggests that's a good trade. So the zero cost deterministic ingestion pipeline. This connects literally directly to MemPalace's most practically useful feature. The ingestion pipeline has zero API cost. The write path is entirely deterministic. Raw fields and conversations go in. They are chunked at 800 characters and 100 character overlap, given an MD5 hash as an ID, and land in ChromaDB. No LLM is ever called, no API charges. So compare that to MemZero or JEP, which charge per token for every memory write. If you're indexing months of conversation history, those costs add up fast. MemPalace lets you do that for free offline and no data leaving your machine. For privacy sensitive application, that's a real differentiator. So minimal wake up cost of the 4-layer stack. The other genuine innovation in how MemPalace handles what I would call the cold start problem. Every time you start a new conversation, how much context does the memory need to inject to be useful? So think of it like a computer's memory hierarchy. MemPalace has 4 layers. L0 is user written identity, about 100 tokens, always present, like your name and role. L1 is an auto-generated essential summary, 5 to 800 token. Together L0 and L1 give you a baseline injection and of only about 170 tokens. L2 kicks in on demand when a relevant topic is detected, 200 to 500 token per topic, and L3 is a full deep search, unlimited tokens triggered per query. This tired this tired design means you are not paying for heavy context on every message. MCP integration and the Palace protocol. Quick note on how MemPalace integrates with AI assistance. It runs an MCP server, model context protocol, which is a standard that lets AI models like Claude call external tools. So MemPalace exposes about 20 tools through this interface: search, query, and query the knowledge graph, then the list, wings, and rooms, and so on. So what's interesting is something the paper calls the Palace protocol. Embedded inside the status tool output is a prompt that instructs the AI, before you respond about any person or topic, call the search tool first. Never guess. That's actually smart prompt engineering. It forces the model to ground its answers in stored memory rather than relying on parametric knowledge. The paper notes this artificially boosts apparent retrieval intelligence. It's a behavioral fix as much as technical one. Next, the memory architecture diagnostic matrix. So how does MemPalace actually compare to its competitors? This matrix is the clearest way to see it. MemPalace raw, it's about 96.6% recall, zero write cost, and lossless fidelity. The weakness is relational depth. It only stores flat triples in its knowledge graph. So complex relationships across time are hard to query. So Mem0, which is 93.4% with their new token efficient algorithm, but costs about 90 to $249 per month and uses lossy extraction. JAP slash graphite is around 85%, about 25 plus, then dollar plus, and has a strong temporal knowledge graph for tracking how facts change over time. Supermemory ASMR hits about 99%, but requires a paid LLM pipeline. So no system wins on everything. The right choice depends entirely on whether your constraint is cost, fidelity, or relational depth. Synthesis, the ergonomic illusion. So here's the synthesis, and it's the most quotable line in the paper. The metaphor is the UI, not the database. The wing, room, hall, drawer hierarchy is a cognitive scaffold for a human user. It gives us a mental model for where our information lives, and that's a genuinely valuable for onboarding, for explaining the system to non-technical users, for making memory feel navigable. For the AI, none of that exists. It's operating in a 348 dimensional vector space, doing cosine similarity math. The metaphor is doing real work, just not the work that was claimed. It's inference design, not retrieval architecture. So one more important update: when MemPalace app launched, the gap looked dramatic. Extraction-based Mem0 was at around 49% on long mem evolution. So MemPalace's verbatim approach jumped to 96.6%. That looked like a paradigm shift. But Mem0 is responded quickly. Their new token efficient algorithm reached 93.4%, proving that extraction can be optimized, and the gap between approaches is now within statistical noise for most practical use cases. So Mem0's enduring mod is no longer raw recall performance. It's the combination of fully local operation, zero API cost, and offline privacy. Those are real advantages. They are just different advantages than the ones originally claimed. So the simplicity paradigm. I will close with the big picture takeaway. The legacy of MemPalace, according to this paper, is a simplicity proof. The field has assumed AI memory required complex agentic pipelines, LLMs reading conversations, extracting facts, building temporal graphs, running reflection loops. MemPalace showed that's not always true. Sometimes you just need to store everything verbatim, embed it well, and give humans a useful metaphor to manage it. You don't always need the complex system on the left. Sometimes the grid on the right is enough, and that's the lesson worth taking seriously, not just for memory systems, but for how we approach AI infrastructure designs in general. Thank you.